All right, letter D, here we go. 3.5x equals 130 plus 10x. Okay, so I got my coins over here by themselves. I need to get these pouches together. I don't want to move that 130, so I'm going to bring this over here. So what I'll do minus 10x and minus 10x. I'm going to make that 10.0x to make sure we see those decimal points line up. This is going to cancel. Now to do that work, remember, even though it's funky, we can reverse it, and we're going to be subtracting because the signs are different. So if I rewrite that here as 10.0 minus 3.5, I get a 6.5. Now remember, it's going to be a 6.5x, but because this is a number, it's further from 0, I take that sign with it. So it's going to be a negative 6.5x equals negative, or equals the 130. All right, so now I'm going to work with this here. I'm going to divide by that negative 6.5 and divide by negative 6.5. This is going to be plain old 1x. And now because it's division and it's a division of a decimal, I need to make sure I look at this. This is different signs, so my answer will be negative. I don't want to forget that part. So what I need to do, this is going to be 130, but because there's going to be a swoop there, I'm going to add another 0 and divide by 65. Turns out that 65 goes into 130 2 times. Because 2 times 5 is 10, 2 times 6 is 12, plus 1 is 13. That's 0, bring down my 0, it's going to go in 0 times. So it's going to be 20, but it's going to be a negative 20 in that case. So let's check that here. So now I'm going to have 3.5 times negative 20. Is that going to equal to 130 plus 10 times negative 20? Man, some big numbers here. Let's take a look. So if I do 3.5 times 20, it's going to be 0. This is going to be a 10, 6, and 7. So one decimal point. This is going to be a negative 70 is equal to 130 plus, and we have to do this one here. This is going to be a 10 times 20. So I got my 0, 0. This is going to be 2. It's going to be a 200, but it's going to be a negative 200. So look at this. If I add to these, I'm going to be subtracting them. So if I do 200 minus 130, there's my negative 70. So negative 70, that does check. All right, letter E on 2. Here we go. 15 minus 4x equals 10x plus 45. Now we've got coins on both sides and pouches on both sides. So in this case, it depends on where you want to work with. We've got more coins over here. And so we want to move that over here. So let's do that part first. If I do minus 15 here and minus 15 here, that's going to cancel. I'll have a negative 4x equals 10x. And here we go. This is subtraction. So 5 minus 5 is 0. 4 minus 1 is going to be 3. So it's going to be a plus 30 there. Then I have this other one here too. And we get the pouches together. Well, I got to get them on the other side over here. So this is a positive 10x. So you just subtract it. So minus 10x here and minus 10x here. This cancels. Now look at this. These are both negative. So same signs, add and keep. This is going to end up being a negative 4 plus 10 is going to be 14x equals 30. Okay? I know this doesn't look nice and clean, but that's the way it works sometimes. It's okay. We're going to divide by negative 14 and divide by negative 14 here. This is going to become a positive x, and then here's my answer. I've got 30 over negative 14. I mean, we can go to decimal, we can leave it a fraction. I'm actually going to simplify this and make this come down to dividing them both by 2. I would have a negative 15 over 7 is my answer. That is really, really messy, but that's okay. We're going to leave it that way. You can put it into 2 1/7, whatever you want to do, but I think working with this will help out when we plug it back in to check. So let's try that out here. Here we go. So I'm going to have 15 minus 4 times negative 15 over 7 is equal to 10 times negative 15 over 7 plus 45. Okay, let's do this side first. So if you recall, when I do this, this is going to be a 4 over 1. I can't do any cross canceling at all. So this is going to end up being a 4 times, actually be a negative 4 times that, counting that there. So negative 4 times negative 15 is going to be a negative 60 over 7, which when I do that work, 7 goes into 60 8 times. Actually, it's going to be plus because there's negatives there. Negative, negative. 7 goes into 68 times, or 56 with 4 left over, so 8 and 4/7. It's It's going to be plus that 15. So the negative and negative made that positive. I missed that point here and come down here to be that. All right, same process here. We know cross-canceling opportunities. So I'm going to have here a negative 150 over 7. I don't know my 7's that far in, so let's actually do that work. I'm going to do that down here. 150 divided by 7 is going to go in 2 times. And 1 there. Okay, so I'm going to stop here. I'm going to use that remainder because it's going to end up being my fraction. So I end up having, this is going to be a negative 21 and 3/7. Use that 21 and 3 in the 7th there. And I have a plus 45. Next part here, you see what's happening? We're going to be doing 15 plus that. So basically 15 plus 8 is going to be a 23 and 4/7. That's what this side equals. This is a little bit messier over here. Let me set this one up. So we have a 45, because I'm going to be subtracting them. This is a higher number here. So 45 minus 21 and 3/7. Now, I got to be able to subtract these. Remember, I have to borrow a whole number. So this becomes a 4. I'm going to bring a whole 1 over here, but I'm going to make it be equal to this so I can work with it. So I'm going to make it a 7 over 7. Change that 1 whole I borrowed to do this. So I've got my 4/7. 4 minus 1 is 3, and 4 minus 2 is 2. Hey, look at that, 23 and 4/7. Wow, that was a lot on those last two with that working. But you guys are gonna have this. This is gonna be what you need to be aware of. It's practicing all of those things that you learned back in, started in 4th grade with fractions and decimals, bringing it into 5th grade and 6th grade fractions and decimals. One question can have you practicing all of these skills all at once. That's why they're so, so important. All right, let's move on to the next part. All right, A3A. So we now have some of these equations that are in that factored form that we practiced last problem, but we're going to work with them in a manner that we can work through this here. So we're going to do a distributive property to take away those parentheses here. So I would do 3 times x, which is going to be 3x. 3 times 1 is going to be plus 3 equals 21. 3 pouches, 3 coins, and 21 coins, okay? So we're going to subtract 3 here, subtract 3 here. This is going to be gone. 3x is equal to 21 minus 3 is going to give me an 18. Divide by 3 here, divide by 3 here. This is going to be x. 18 divided by 3 is 6. Let's check that here. Let's go back to this one here. Look at that. If I actually do this 3 times 6 plus 1 equals 21. 6 plus 1 is 7. So 3 times that equals 21. That checks. All right, next one. 2 plus 3 times the quantity in parentheses x plus 1 is equal to 6x. Same process we just did. We're going to distribute that 3 through. Have a 3x here. Distribute that 3 here. Do plus 3 here. I bring my plus 2 here and my 6x over here. All right, now before we do any moving around of pouches and coins, notice how I've got some loose coins on both sides here, on this one side. I've got a 2 plus 3. Let's simplify that and put that together first. So 5 plus 3x equals 6x. All right, so here we go. We got to get these pouches together. So minus 3x here, minus 3x here. This cancels. I got 5 is equal to 6x minus 3x is going to be a 3x. Now, some of you might have noticed here that our x's have almost always ended up on the left side of the equal sign. It doesn't matter what side they end up on. So if you like it better to have the x over there, just do your work to bring the coins over and do that way. But ultimately, it's not going to matter either way. Same process here. Divide by 3 and divide by 3. This is going to be a plain old x, and I've got 5 over 3 as my answer. And I'm going to leave it that way, or I could do 1 2/3. Either way is going to be fine. Okay? Let's check this one here. So I'm actually going to leave it in this format. I'm going to look at this guy here because I already simplified that to plug these in. So I would do 2 plus 3 times 5 over 3 plus 3 is equal to 6 times 5 over 3. Let's do that first. So 3 times 5 over 3. Remember, this is going to get 3 over 1. These guys will cross cancel, be left with a 5. So I have a 2 plus 5 plus 3. 2 plus 5 is 7, plus 3 is 10. Let's see if that works over here. Same here, this process. I could cross cancel, or I could leave it that way, but you'd see I would have a, I should just cross cancel. This is going to be a 1, this is going to be a 2, because 3 divided by 2 is going to go in here. Divided by 3 on both of those cases. 2 times 5 is going to be 10, and there it is, 10 equals 10. All right, A, 3C. Let's take a look at what we have here. So again, we've got negative 2 times the quantity in parentheses, 2x minus 3 equals negative 2. So let's distribute that through. Now be careful, this is a negative 2. Negative 2 times positive 2x is going to be a negative 4x. And then a negative 2 times that minus 3 is like negative 2 times negative 3. It's going to end up being a plus 6 equals negative 2. All right, we got pouches here. We're going to leave that alone. And we got coins here and coins here. Even though it's negative, they're still treated like coins. So minus 6 here, minus 6 here. This is going to cancel. Negative 4x is equal to, okay, look at same signs, add and keep. So I have a 2, negative 2 minus negative 6. Same signs, add and keep. Going to be a negative 8. Divided by negative 4, divided by negative 4. This is going to be a positive 1x. Negative 8 divided by negative 4 is positive 2. Let's go ahead and check that one here. So I'm going to do that. I'm going to come back up and use this one here. Negative 2 times, here we go, 2 times 2 minus 3, is that going to equal negative 2? Let's do that work in here. This is going to be a 4 minus 3, which would give me a 1, times negative 2. Does that equal negative 2? Yeah, negative 2 times 1 is negative 2 equals negative 2. Check. Wow, those were a lot of equations that we went through and solved. Hopefully that's going to be helpful to see that. I know it was a little bit quicker than we would have done it in the Google Meet, but please make sure that you go back and look at the work. And if you have any questions, please bring them. All right, the next section for part B, we actually have some other students doing their work, and we got to look at it to see if they made any mistakes or not, or if they did it accurately and may have thought about it in a different approach. So let's take a look at those now. Okay, here are the examples of student solutions to questions from A, part 3 above. Is the solution correct? So this is work that we just got done doing in part 3. All those ones with the fractions, or sorry, with the fractions, with the parentheses. So let's see if there's a mistake. Are they correct, or is there a mistake? Here we go. So Corey's solution. He has number 3A. If you recall, when we did that, we already knew the answer here was going to be 6. So let's take a look to see what we get for that. So he's Corey's solution. He says 3 times something in parentheses must be 21. So something in here. So 3 times that something's going to be 21. Well, that something is 7, because we know 3 times 7 is 21. So then if I've got an x plus 1 equals 7, that means that that x has to be 6. I agree with that. We saw that here in our work. It's a different way of looking at it, but it does have the x equals 6. So I agree. Look at number 2, or the next one here. We've got Hayden's example. We've got that 2 plus the 3 times the x plus 1 is equivalent to 5x plus 1. Okay, so he's got from a 2 plus 3 to make 5x. So I can rewrite the original equation as 5x plus 1 equals 6x. Using distributive property, this is the same as 5x plus 5 equals 6x. Subtracting 5x from both sides, I get 5 equals 1x, so x equals 5. Okay, so let's look at our work. We had the answer was 5/3, and we checked it to make sure it was right. So if I look back at this, the initial step, I see a problem right here at the very, very beginning. By order of operations, remember PEMDAS, we have to go parentheses, exponents, multiplication comes first. So they added first to get this here. So that's why Hayden's is incorrect. All right, the next one here. We have letter C, it equals a positive 2. Let's take a look here. All right, so Jackie's solution in this case had that same problem. So by using distributive property on the left-hand side of the equality, I get here. So if you remember that negative 2 times 2x, they get negative 4x. Then negative 2 times that minus 3, they have a minus 6 equals negative 2. By adding 6 to each side, I would get negative 4x equals 4. By dividing both sides by negative 4, I'd get x equals 1. Well, that's where we had a positive 2. Where's the error? I look closely at it. Negative 2 times 2x, that's the 4x. Look at this, negative 2 times negative 3. Remember, we just mentioned that. It's negative times negative. That would be a plus 6 right there. So that's the error that we would see. Hopefully that made some good sense there. I do know that those errors are very, very common, especially for Hayden's and Jackie's solutions, where there's a mix-up of the order of operations or the distributive property isn't done completely of both parts. You will find out that if you go to check your work and there's not a correct answer on both sides of those equal signs at the very end, you might have made one of those errors, and you need to go back and check on those. All right, let's take a look at the next part.